Hey everyone, and welcome to this explainer on the law and ethics of autonomous vehicles. I'm honestly so excited to dive into this with you today because we are standing right on the absolute edge of the most massive revolution in human mobility since, well, the invention of the automobile itself. We aren't just talking about cars getting a little bit smarter here. We're talking about a very imminent future where the actual act of driving is completely handed over to machines.
But before we get totally lost in all that futuristic gloss, let me hook you with a pretty high-stakes scenario. Picture this. Your car is driving itself. It causes a fatal crash. So, who actually goes to jail? Is it you, the person just chilling in the driver's seat reading a book? Is it the software engineer who wrote the code? Or is it the multi-billion-dollar manufacturer? We're diving straight into this incredibly complex web because this isn't just some tech issue. It's a profound legal and ethical crisis that lawmakers are scrambling to figure out right this second. All right, let's jump right into Section 1. What it takes to drive. How autonomous cars work.
Okay, so to truly understand the law, we have to ground all these futuristic concepts in the tangible reality of the hardware and the software that's making it happen. I want you to imagine navigating a wild, chaotic web of roads like this. Think about all those split-second, gut decisions you make when merging, the sort of unwritten social rules you use to negotiate who has the right of way, and just the sheer unpredictability of human behavior. Now imagine trying to program a computer to not only survive that chaos, but to navigate it flawlessly. The challenge this artificial intelligence faces is literally staggering. To tackle that massive challenge and actually replace a human driver, the car basically relies on three anatomical parts. First, you've got the sensors. Think of these as the eyes. We're talking cameras for visual perception, LIDAR systems bouncing lasers around to map the world in real-time 3D, and radar to cut through bad weather and detect speed. Second is the control unit, the brain. This is the computer crunching an unimaginable amount of data in milliseconds, predicting what pedestrians might do and charting out the absolute safest path. And finally, the actuators, the muscles. These are the physical components that take the computer's commands and actually physically turn the steering wheel, hit the brakes, or hit the gas.
Now, just like a commercial jet has a black box, these autonomous cars require what's called an EDR, or an event data recorder. It captures and basically memorizes the exact technical events, the raw sensor data, and the actuator commands in the seconds right before an incident. When a machine replaces a human, this black box essentially becomes the ultimate unbiased witness in a courtroom to figure out exactly what went wrong.
Moving on to Section 2, the 6 levels of autonomy, from human to machine.
So, whenever you read an article about self-driving cars, you'll inevitably hear people talk about levels. This actually comes from the SAE, the Society of Automotive Engineers. They created this universal 0 to 5 classification framework. You really need to understand this scale to know exactly what it means when an automaker claims, hey, we've got a self-driving car.
The absolutely crucial transition here happens right between Level 2 and Level 3. Level 0 is entirely you, the human. Level 1 is basically just simple cruise control. But pay close attention to that monumental leap between 2 and 3. At Level 2, the car assists you, but legally, you are the driver. You have to supervise constantly. But hit Level 3, conditional automation, and the machine officially takes over the driving task. You're actually allowed to look away from the road, but you have to remain on standby to take over if the car gets confused and asks you to. It's the exact moment the legal liability starts shifting away from the human and on to the machine.
So, thinking about that 0 to 5 scale, where do you think we are right now? Just take a quick guess at where our current everyday technology actually sits out on the road today.
If you guessed that we're mostly hanging out at Level 2, you hit the nail on the head. Level 2 is very much the current norm. Think of Tesla's Autopilot or GM Super Cruise. The human is still totally responsible. But Level 3 is just starting to emerge. Mercedes-Benz actually deployed its Drive Pilot in Germany recently, allowing entirely hands-free driving up to 95 kilometers per hour in very specific highway traffic. Level 4, where the car needs zero human intervention, does exist, but only as these geofenced robotaxis like Waymo over in San Francisco. And Level 5, a car that can drive literally anywhere, anytime, in any weather with absolutely no steering wheel? Yeah, that does not exist on the market yet. Which brings us to Section 3, rewriting the rules, the clash between old laws and new tech.
This is a pretty fascinating legal culture shock. On one hand, we have the bedrock of international road law, the 1968 Vienna Convention on Road Traffic. For decades, this treaty strictly mandated that every moving vehicle absolutely must have a driver who is constantly in control. Obviously, an autonomous car breaks that 1968 rule the second you turn it on. It wasn't until a 2022 amendment, Article 34 bis, that international law finally stepped up and allowed a machine to legally take the wheel, provided it meets some very strict technical regulations.
But of course, this creates a massive unresolved gray area, particularly for those Level 3 vehicles we talked about. Remember, at Level 3, the car drives, but if it encounters something weird, it asks the human to take over. But here's the billion-dollar question. How much time do you actually get? Is it 2 seconds? 10 seconds? The law still hasn't harmonized exactly how many seconds you have to drop your phone and retake the wheel. This takeover time gap is a huge blind spot, and mark my words, it is exactly where future lawsuits are going to be fiercely fought.
Let's look at Section 4, Privacy and Cyber Attacks, the invisible threats.
Making a car incredibly smart also, unfortunately, makes it a massive data-gathering machine and a giant potential target. So, can a multi-ton, fast-moving vehicle actually be maliciously taken over by a hacker? It's the question everybody secretly worries about the minute they hear the phrase, computer on wheels.
Well, the scary reality is yes. Remote hacking and sensor manipulation are very genuine risks. I mean, if someone hacks the LIDAR, they could literally make the car see a brick wall that isn't even there, or worse, ignore a pedestrian who is. And speaking of pedestrians, think about the privacy implications. These cars are covered head to toe in high-definition cameras, constantly filming our streets. In Europe, that is a massive GDPR privacy nightmare. Are they just recording every single person they drive past? To combat this, the law now mandates cybersecurity by design, meaning tight security has to be baked into the foundation from day one, not patched in later. Automakers also have to use privacy-enhancing technologies, or PETs, to instantly blur and anonymize faces and license plates. All right, Section 5, who pays when it crashes? The shift in liability. Under the traditional model we're all used to, if there's a crash, you immediately look at human fault or negligence. Did the driver text? Did they run a red light? But once you reach levels 4 and 5 autonomy, the driver is basically just cargo. The liability shifts entirely away from human mistakes and lands squarely on the manufacturer. An accident transforms from a traffic violation into a product defect or a software failure. The automaker suddenly becomes the responsible party.
Now, why does it work this way? Because of a rather brilliant economic and legal theory called the cheapest cost avoider. This theory argues that liability should always fall on the party who can prevent the damage most efficiently. Think about it. As a consumer, you can't exactly go in and reprogram the AI to be safer, right? You don't write the code, but the manufacturer does. Because they hold the power to fix the software, they are the cheapest cost avoider, and therefore they absolutely must foot the bill when their tech fails.
And that leads us to our final, and definitely our heaviest, topic. Section 6, the ethics of AI driving. Programming life and death. Back in 2017, the German Ethics Commission established this incredibly profound real-world ruling. They stated all human lives have an equal value. A vehicle cannot decide to save a child over an elderly person. I want you to treat this like a giant thought experiment. In a split-second panic, a human driver might instinctively swerve to avoid a stroller, even if it means hitting someone older. But currently, regulators are absolutely refusing to let algorithms mathematically weigh the value of different human lives. Strict equality is the absolute rule.
So the real crux of the issue is the immense, mind-bending difficulty of ethical annotation. How do you literally code what is right and wrong into a machine? Because in an unavoidable crash scenario, the algorithm has to make a choice. By law, there is a total rejection of any human hierarchy. The car cannot discriminate by age, sex, or how vulnerable someone is. To keep track of all this, legal experts are demanding an ethical black box so we can audit exactly why an AI made a fatal choice. It highlights this intense, fascinating tension between human utilitarianism, the instinct to save the most vulnerable, and strict, cold legal equality.
I really want to leave you with this highly provocative thought, because I think it encapsulates this entire debate perfectly. In an unavoidable crash, who would you want your car to prioritize? Would you want it programmed to protect you, the owner, at absolutely all costs? Or would you want it to be programmed to sacrifice you if it means saving a larger crowd of pedestrians? It's a really heavy question, but as machines increasingly take the wheel, it's a question we literally can no longer afford to ignore.
I really hope this explainer sparked your curiosity and helped you understand the fascinating road ahead. Keep learning, and I'll see you next time.